Good day. This next video will be an introduction to triangle congruence. Uh, Suppose we have this correspondence between two triangles. Say triangle ABC, there's a correspondence with triangle XYZ. This means that A corresponds to X, B corresponds to Y, C corresponds to Z. So as uh, drawn here, when we have two congruent triangles, if triangle 1 is congruent to triangle 2, then each pair of corresponding angles should be congruent. So here, these are corresponding angles. So we are saying that angle A should be congruent to angle X, angle B should be congruent to angle Y, and angle C should be congruent to angle Z. Okay, so this is the first requirement. This is the same requirement when we said triangle 1 is similar to triangle 2. Okay, the second requirement for two triangles to be congruent will be each pair of corresponding sides should be congruent. Okay, that means this AB corresponds to XY, so AB should be congruent to segment XY. BC corresponds to YZ, so they should be also congruent, and side AC corresponds to XY, so they should be congruent. So this is the second requirement for uh, the two triangles to be congruent. So note here that both the corresponding angles should be congruent and the corresponding sides should be congruent. In terms of proportionality, the constant of proportionality here, let's say AB is to XY as AC is to XZ, and then BC is to YZ. The constant of proportionality here is equal to 1. We have a perfect similarity. That's why if we have K equals 1, you cross multiply this, you have AB will be equal to XY, etc. AC here equals XZ, and BC is equal to YZ. Now, note that these are segments, these are sides, and these are their lengths, okay? There's no bar on top, so these are real numbers, okay? So, now, if triangle ABC is supposed to be congruent to triangle XYZ, ABC congruent to triangle XYZ, then this should hold true. Okay? That's what we mean by two triangles congruent. In terms of similarity, we have K equals 1 for the proportional sides, which in fact we have a perfect similarity. Perfect similarity means K equals 1 and the triangles are congruent. Now, before we even get to proving, let's see. For example, uh, you have this triangle here, uh, and I'll ask you, okay, suppose we have this triangle here, and then I have this triangle here. Let me erase that. Uh, I have this triangle here. Let's say I will have here A, B, C, and then say X, Y, Z. If the correspondence A, B, C, and then uh, this should be X, Z, Y. I'm sorry. This should be X, Z, X, Y, Z. This should be Y. This should be Y. Can I erase that? May I erase this? Okay. Um, X, Y, Z. If we have that correspondence, A, B, C, and X, Y, Z, then if we want this to be congruent, if triangle 1 is congruent to triangle 2, then we need to have the corresponding parts congruent. So which are the corresponding parts here? From this correspondence here, angle A here corresponds to X, angle B corresponds to Y, angle C corresponds to Z. Therefore, for triangle ABC to be congruent to triangle XYZ, uh, by definition, we should have the first requirement. We have angle A corresponding to angle X should be congruent. Uh, Angle B corresponding to angle Y should be congruent, and angle C corresponding to angle Z should be congruent. And the corresponding sides, AB should be congruent to side XY, AC congruent to side XZ, and BC congruent to side YZ. Okay? So the only difference between similarity and congruence would be letter B, where the constant of proportionality is equal to 1. Okay, now, the next concept that I want to discuss with you will be, um, suppose we have here triangle A, B, C. Now, this side here and this side here will have this included angle. So, angle A here, angle A is termed to be the included angle of sides what? AB and AC. Okay, so side AB and side AC, angle A is the included angle. Now, which sides will include angle B? Which sides will include angle B? So if angle B is the included angle, which sides will that be? That will be the one that will enclose it, AB and BC. And what about angle C? If angle C is to be an included angle, then we have what? Sides what? AC and BC. AB, BC, AC. Okay, so here, angle B is the included angle of side AB and BC. Angle C is the included angle of side BC and AC. And angle A is the included angle of side AB and side AC. Now, it's important for you to know that what it means to have an included angle here. Okay, now, let's get the other version. This AB here, side AB here, side AB is the included side of two angles, angle A and angle B. Okay, so angle A and angle B, this will be the included side. Okay, what about BC? BC is the included side of angles what? B and angle C. Okay, and then what about AC? AC here, this end angles here will include it. So AC is the included side of angle A and angle C. Okay, so we need these terms, included angle and included side, because these are the bases for our showing the two triangles are congruent. Okay, uh, let me show you this one here. Okay, so these are the postulates that will allow us to prove that two triangles are congruent. The SAS correspondence is a congruence, which means if two sides and the included angle, SAS, two sides and the included angle uh, are congruent. Okay, so this is two sides. For example, you have here another triangle here. If this is congruent to this, and this is congruent to that, and this angle is congruent to this angle, then we have an SAS correspondence, which is a congruence. Okay? Which means, if you want to prove triangle ABC, XYZ, to be congruent to each other, then you have to find two sides. This is the first pair of side, and then this is the second pair of another side. So this is another side, and the included angle here, they must be congruent. Okay, so S congruent to this congruent to that, and the included angle should be congruent. And we say that triangle ABC is congruent to XYZ by the SAS correspondence postulate. Okay, now you would be able to guess what ASA here is. Okay, suppose I have again triangle ABC, and I'll have here triangle XYZ. For you to use the ASA postulate, we need to have angle, side, angle. So we have an included side. Suppose this side here, uh, uh, okay, suppose this side here is the included side, and this side is the included side here. It must be that this is congruent to this, and the corresponding angles that include that side should also be congruent. Okay? So we have that marking. It should be SAS. SAS. So this SAS correspondence, if they are congruent, then we can say that the two triangles are congruent by the ASA postulate. Okay? Let's have the SSS. So suppose we have these two triangles, A, B, C, X, Y, Z. For them to be congruent by SSS, then three sides. We need to have each pair of corresponding sides be congruent. So if this is congruent to this, and this is congruent to that, and this is congruent to this, then we can say that these two triangles are congruent by the SSS postulate. Look at the markings that I'm making. This one is one tick mark. This is another tick mark. So this means this congruent side is, this side is congruent to that side. This one here corresponds to that. So these sides must be congruent. And so on. This one is congruent to that side. Okay. So these are the congruence postulates, SAS, ASA, and SSS. These two theorems also will allow you to prove that two triangles are congruent. We have an SAA, side angle angle. So you can imagine that we have here side and then angle angle. This side angle angle. And you can have congruence on triangles using this theorem. Okay. Now also we do not have an SSA. We don't have SSA. We have SAA congruence, but not what? Not SSA. Not side-side angle. And the last one will be the hypotenuse leg theorem, where this one applies only when we have two triangles, which are right triangles. Again, we can prove two triangles congruent using these three postulates and three uh, these two theorems. Okay, we will apply these postulates and theorems in the next video. Okay.